Hello and welcome to Algebra 2 3.05 notes. And we're going to talk today about multivariable equations, which means we're talking about equations in three variables. So up until now, you guys have done quite a bit of work with systems of equations using two different variables. You did linear system of linear equations in middle school and in algebra. And then last class, we talked about using system of equations with a linear and a quadratic equation. So we looked at circles and lines, or parabolas and lines, or even parabolas and circles. And now we're going to talk about three variables. So before, with two variables, you needed two. If you had two variables, then you needed two different equations. If you had one variable, you only need one equation to solve it. So if you have three variables, you're going to need three equations. And what this is instead of just having a line, is we're talking about a plane. So different planes intersecting with each other. And when that happens, a plane, think about a plane like the floor or the wall, and imagine that it extends forever in all directions. And when these planes intersect, they intersect to form, when two planes intersect, they intersect to form a line. So you could have your three different planes intersect to form a line. You could also have all three planes intersect to form just to meet at exactly one point, or you could have parallel planes, which means you wouldn't intersect at all. So you wouldn't have any solution. All right, so let's try to start one of these. So we're going to solve for x, y, and z algebraically. And our three equations are x plus y plus z equals 6, 2x minus y plus z equals 3, and 3x minus z equals 0. Now these are usually pretty long problems. Usually I give myself a page for each one. And it's important that you kind of think through it first. A lot of students are very successful with these, but they definitely take some time to figure out the process, and you need to think through it. Students are often pretty good at doing their two variable systems, so try to think about your process of elimination when you do these. So we want to use typically elimination. You can use substitution, but usually it's a little bit harder. So I recommend using elimination. And you want to eliminate the same variable two times. Eliminate the same variable twice. Because you want to get two equations in the same two variables. Okay, so first thing I want to do is I'm going to change colors here, and I'm going to label them. So we're going to label our work as we go, because these do require a lot of work. So this one I'm going to call E1, E2, E3, meaning equation 1, equation 2, equation 3. So my first step is I'm going to take two equations at a time, and I want to eliminate the same variable two times. So first I'm going to take a pair of two equations and eliminate one variable. Let's just take a look at our three equations to decide which one we want to do, which one's going to be the easiest. So looking at equation 1 and 2, if I were to add those two equations together, I'd notice my y's would drop out right away. So it would be very easy to eliminate y. Well, if I look at equation 3, that one actually only has two variables. So if I can get the equation 1 and equation 2, if I can eliminate y from that, I would have another equation in just x and z. Again, I want two equations in the same two variables. So I want to get two equations that have just an x and a z in them. So the first thing I'm going to do is eliminate the y. So I'm going to take equation 1 plus equation 2, because you'll notice right away those have opposite signs and the same coefficient, so they're additive inverses of each other. And same process as when you guys have done elimination. It's kind of like you're looking for almost like a common denominator, and then you're going to add the equations together once you get them to be the same number but opposite signs, so additive inverses. All right, so I'm going to add straight down here. So I have 6 and 3 is going to give me 9. Z plus z is 2z. My y's cancel. 1x plus 2x is 3x. So let's call that equation 4 now. Okay, now I'm going to go this direction. Step 2, I want to take this equation here, and I have another equation in x and z. So I have 2 equations in the same 2 variables. And that now we're right back to where you guys were in algebra when you solve systems of equations. So to do that, I need to now get one of either the x or the z to drop out. Now I see I have a 3x here and a 3x here. So they already have the same coefficients. I just need one of them to be negative. So I'm going to negate E3 and add that to E4. Another hint here, I never want you to subtract the equations. You're always adding them. So you can add a negative equation, add negative E4 if you wanted, but I always want you adding. Very, very, very important. So you can negate the whole equation, but then I want them added. So if we negate E3, so I'm going to multiply E3, which is 3x minus z equals 0 by negative 1. So that gives me, if I distribute my negative 3x plus z, and 0 doesn't have a sign, so I just leave it. Now I'm going to write my E4 right underneath. So this is negative E3, and E4 is 3x plus 2z equals 9. And then I'm going to add those together. So I'm just going to make a line so you don't get confused with that. All right, so those cancel out. Z plus 2z is 3z, and 0 plus 9 is 9. Now I just have z, so I'm going to solve. So I'm going to divide both sides by z, by 3, and I get z equals 3. Good news, I am a third of the way there. I need to find, or I have a third of my answer, I should say. So I have z equals 3. I now need to find x and z. So the next thing you want to do is sub into one of your 2 variable equations. So find one of your equations that has only 2 variables. Sub into a 2 variable equation. So typically, we might not always have, like in this one, the third equation was 2 variables, but oftentimes that's not going to happen. So usually you're going to have to use like one of these ones that you got after eliminating a variable. So let's use that one for now, since that's what you often will be doing. So 3x plus 2z equals 9. I'm going to sub in z equals 3. So 3x plus 2 times 3 equals 9. Now I have 3x plus 6 equals 9. Subtract my 6, and then divide by 3, and I get 1. So now I have my x, I have my z. The last thing I need is my y. So step number 4 is sub in to find y. So here you need an equation that has y in it. So I can't use equation 3 or 4. They don't have a y. I can use 1 or 2, and it doesn't matter which one I choose. So I'm going to choose E1, which is x plus y plus z equals 6. And so I'm going to sub in 1 in for x, a 3 in for z, and leave my y in 6. Combine my like terms. I have 4 plus y equals 6. And then solve for y by subtracting my 4 to get 2. So now I have y equals 2, x equals 1, z equals 3. The last thing I want you to do is write out your solution as an ordered triple. And it always goes in alphabetical order. So x, y, z. If you had other letters like A, B, C, it would go in alphabetical order. So our X is 1, our Y is 2, and our Z is 3. So these 3 equations will all intersect at exactly 1 point. Pretty cool. Let's try another one. Solve for X, Y, and Z. Here are your 3 equations. 9x plus 6y minus 8z equals 0. X minus 2y plus 4z equals 24. And 3x plus 6y plus 10z equals 84. I'm going to switch colors, and I'm going to label them my E1, equation 2, and equation 3. So the first thing you want to do is really think about your plan of attack here. We need to try to get 2 variables, 2 equations in the same 2 variables. That's your main goal. That's what I want you to be saying to yourself. 2 equations in the same 2 variables, which means I need to eliminate the same variable twice. So in the last one, I said that, but we actually only needed to eliminate it once because our third equation only had 2 variables in it. Here, we're going to have to eliminate it twice. So take a look at your equations first to try to find the easiest plan for yourself. So which ones can we easily eliminate? In this case, we don't have the same number, same coefficients in front of our letters, our variables. So we're going to have to multiply by something. So you might look here and you might say, oh, well, I do have 2 6s in E1 and E3. So that might be easy. And then I look at the middle one just to be sure, and I can multiply that by 3 to get it to become a 6 as well. So the y's look pretty easy to do. The x's also look very doable. You could multiply equation 2 by -3 to get it to cancel with equation 3. You could multiply it by -9 to get it to cancel with the 9x in E1. And then even E3, you can multiply by -3 to get it to cancel with the 9 in E1. Z's are definitely the most challenging. The first top 2 equations are not too bad because you could just multiply the 4 by 2 to get it to cancel with your E1. But then the 10 would be a little more challenging. You'd have to multiply both equations by something to get them to cancel out because I can't make a 4 into a 10. So I would maybe multiply equation 2 by 5 and then equation 3 by -2 to get them to both become 20 and -20. So I'm going to stick with the y's today, but either x's or y's is fine. So I'm going to eliminate y, which means I'm going to need to do that 2 times. First, I'm going to look at equation 1 and 2. To eliminate my y, I need to multiply equation 2 by 3. So again, you're trying to get these 2 numbers to be additive inverses of each other. So -3 times E2 plus E1. So label what you're doing and then go ahead and do it. So I'm going to take -3. Oh, sorry, we don't need a negative there. Just 3 because the 2 is already negative. So I'm going to multiply 3 times equation 2. Make sure you're careful with those z's. Sometimes they do look like 2's. So that's why I put my line through the middle there. And so then I get 3x minus 6y plus 12z equals 72. So that's 3 times E2. And then I'm going to rewrite E1. So 9x plus 6y minus 8z equals 0. And now we're just going to add straight down. So we're adding those together. So we get 12x, these cancel, plus 4z equals 72. And I'm going to call that now equation 4. So now I have an equation in 2 variables, x and z. My goal is to get 2 equations in the same 2 variables so that I can do what I've done in algebra with just a system of linear equations. So how do I get another equation in x and z? Well, I go back up here. I cannot use 1 and 2 again. And I can't use equation 4 either. And that's a very common mistake that I have students do a lot on tests and quizzes is they then take equation 4 and try to eliminate a variable with one of the ones on the top. You have to use the 3 given equations to eliminate the same variable twice. And it can't be 2 and 1 again, so, or any version of 2 and 1. So equation 4 has 2 and 1 in them. So you couldn't use equation 4 and equation 1 or anything like that. So we can do either equation 1 and 3 or 2 and 3. And it looks like 1 and 3 might be our easiest, but again, it doesn't matter. Actually, I'll show you how to do equation 2 and 3 with it. But again, 1 and 3 they're about the same. So here I'm going to multiply 3 times equation 2 and add it to equation 3. So I already did 3 times equation 2, and I got 3x minus 6y plus 12z equals 72. So now I'm going to write, so that's 3 times equation 2, and then I'm going to take equation 3, which is 3x plus 6y plus 10z equals 84. And I'm going to add those together. I get 6x plus 22z equals 156, and that's my equation 5. All right, so again, I used 2 and 1 first, and then 2 and 3 the second time. Now I have 2 equations that both have just an x and a z in them. So now we're right back to algebra where we have a system of 2 equations in 2 different variables. So now I'm going to use these 2 yellow equations, E4 and E5, to eliminate either the x or the z. So looking at them, I have a 12 and a 6, so I can multiply this x, the 6x by -2, and that would get those to drop out. And that looks like it would be the easiest way to do it. So let's do -2 times equation 5 plus equation 4. So I'm going to take -2 times equation 5, which will give me -12x minus 44z equals -312. Then, so that's -2 times E5, and then E4 is positive 12x plus 4z equals 72. And I'm going to add those together. So I get -40z equals -240. And I want to divide both sides by -40 so I can solve for z, and I get z equals 6. So I have one of my 3 answers now. Okay. Now I need to find y and z. So now it's just a matter of substituting in. So you want to sub in so that you only have one variable when you're solving. So I want to take x equals z and sub it into one of my 2 variable equation. So let's use equation 4. So E4 is 12x plus 4z equals 72. And I'm going to take 4 times 6 equals 72. 12x plus 24 equals 72. Subtract your 24. And then divide by 12. And we get x equals 4. Okay, so now I have z, I have x, I still need y. So last step is to find y. So let's sub into, you can use any of your 3 variable equations. So from the original, I am going to use, let's use equation 2. So we've got x minus 2y plus 4z equals 24. And my x is 4. I'm solving for y. My z is 6. And then just continue solving from there. Pause the video, go ahead, solve for y, and then check back for the answer. Okay, so you should have gotten y equals 2, and that gives us our last piece here. Final answer, there's one solution, and that is x, which is 4, y, which is 2, and z, which is 6. So if you were to graph this, you have three sets of axes in x, y, and z. All right. And we'll do one more. This one I put A, B, and C in here. Solve for A, B, and C. Negative A plus 4B equals negative 1. 2A plus 4C, and I'm spacing them out so like the A, B's, and C's are lined up. And then A minus 2B plus C equals 3. Let's call this equation 1, equation 2, and equation 3. So again, you want to be thinking, I need two equations in the same two variables. So if I look here, I have one equation in A and B, the second one is in A and C, and the third is in A, B, C. So I don't have two equations in the same two variables. So what you can do is focus on one of your equations that you have in just two variables. So either the A and B or the A and C, and just keep one of those as is. So let's keep the A and C. So let's look at the A, B one here. So I want to use equation 1 and equation 3 to get another equation in A and C. So get another equation. This is what I need to get another equation in A and C. So if I want another equation in A and C, that means I must eliminate what letter? B. Because if I eliminate the B, then I will have just A and C left. Okay, so looking at equation 1 and 3, how could I eliminate my B? Well, I have a 4B and a negative 2B, so how do I get them to become additive inverses? I could multiply negative 2 by 2. So let's take 2 times equation 3, they already have opposite signs, and add it to equation 1 for step number 1. All right, so 2 times A minus 2B plus C equals 3. That gives me 2A minus 4B plus 2C equals 6. So that's 2 times E3, and then I'm going to rewrite E1, which is negative A plus 4B equals negative 1. And let's add those together. So 2A minus 1A is just 1A. B's cancel, and I'm just adding 0 here. So 2C plus 0 is just 2C. 6 minus 1 is 5. So now I have this equation that's in just A and C, and I have this equation in A and C. So I have two equations in the same two variables. So two equations in the same two variables. I need to eliminate either the A or the C now. All right, so I have an A here and a 2A here, so let's multiply equation 4 by negative 2 and add it to equation 2. Again, you always should be adding your equations, so I should not see E2 minus 2E4. You could do E2 plus negative 2E4, but I don't want you subtracting equations. All right, so negative 2 times A plus 2C equals 5. And the reason I don't want you subtracting is because there's just too many mistakes with distributing your negative, and it's really important that you just keep it always addition. All right, so I just distributed my negative 2 in. I got that, so that's negative 2 times E4. I want to add that to E2, so I'll rewrite E2. And then again, we're always adding those equations. So I add those down. I add those down to get 0, and negative 10 plus 12 is 2. Huh. All my variables just dropped out. Ah! And is 0 equal to 2? No. So if you end up with a false statement, then we know that it is, we call it inconsistent. And there is no solution. Or you can do the circle with the slash through it. If you end up with a true statement, like 0 equals 0 or 2 equals 2, if it's true, then that tells you you have an infinite number of solutions. So they could intersect in a line because there would be infinite points on that line. But if you end up with a false statement, then there's no solution and you're actually done. So it's a little bit shorter. But sometimes, we get nervous because everything dropped out, but that is okay. And it just means that they don't intersect. There's no solution. All right, that is it for our 3 variable systems. And you guys will have some practice on this. Again, if you have any questions, please let me know. And I hope to see you soon. Bye out.